34.5 should be 45.5. And here, this is what we're looking for. So I kind of expanded this triangle out, and since I know this angle right over here, which is 134.5, is that right? Not sure. Yeah, 134.5 degrees. It's supplementary to that, so that's 45.5. And using the law of cosines, you should be able to figure out what that short length is. Okay. Next, let's look at number 20. 20 is a little bit more difficult. I'm sure a lot of teachers like to give this type of problem on a test. Distance and bearing. So whenever you hear the word distance or bearing, bearing that is, or if you look at like a plane, balloon, anything that's in the air or the sea, they use bearing. And we know that the bearing, the 0 degree marks here, it's counterintuitive. It goes clockwise, positive degree, counterclockwise, negative. So north is always 0 degrees, and then that way is positive, that way is negative. Okay. A man wandering the desert walks 3.3 miles in the direction south 44 degrees west. He then turns and walks 2.2 miles in the direction north 55 degrees west. At this time, how far is he from the starting point? What is his bearing from the starting point? It's actually a man walking, so it doesn't necessarily have to deal with bearing, but they want to use bearing as a reference. So, a man starting at a point walks 3.3 miles. This is number 20, by the way. In the direction south 44 degrees west. Then he walks 2.2 miles in the direction north 55 degrees west. And at that time, how far is he from the starting point? What is his bearing from the starting point? Okay? So, starting at some point, he goes south 44 degrees west. It's going to end up somewhere over here. Then he goes north 55 degrees west. So it's going to go to something over here. So I'm going to start off probably over here somewhere. That's north, okay? So what this says is going south, starting at south, this is your starting point, south, you're going to go 44 degrees west. So west is that direction. East is that direction. So therefore that's west. So he's going to go in that direction 3.3. And that angle is going to be 44 degrees. Okay? And then from that position here, so I have to reset my location. This is going to be my true north again. He's going to go north 55 degrees west 2.2 miles. 2.2, not quite as much as 3.3, but this angle is going to be 55 degrees. And what I'm trying to figure out here is how far he's gone. So this is what I'm looking for. And what's the bearing? This angle right over here. So once you figure that out, he's going west, starting off west. How many degrees? Whatever that degree angle is, and going south. So I'll probably work about a couple more minutes on this problem with you. We know that this is 44 degrees, it's parallel, so we know that this is 44 degrees as well. So let's redraw the triangle. Right over here, nice and neat. Okay. So that's 55 plus 44, and 55 plus 44, I can't do that very well in my head, I don't know why. 99 degrees. And this is 3.3, this is 2.2, and I'm trying to figure out what this is. And that's not going to be very difficult. You're going to use the law of cosines to figure it out. Once you figure out what that distance is, side angle side, then you're going to figure out what that angle is. That's equal to that angle right there. You can actually, you don't have to actually figure out what theta is. You just add whatever your angle, theta, let's call this theta 1. Call this theta 1 plus theta 2. So starting at south, we're going to go 44 degrees plus theta 1, and you're going to go towards the westbound. Once you figure out what theta 1 is right over here, that's your direction. Okay? Give you a lot of helpful hints on this. Shouldn't be too bad. 22, 24, I'm running out of time a little bit. My students should be coming in any minute, so I'm going to have to stop pretty soon. The plane is headed due east with an airspeed of 345 miles per hour. Its true course is, however, is 95.5 degrees from due north. If the wind currents are currently constant 55 miles per hour, what are the possible ground speeds of the plane? This is a pretty tricky problem. So let's see how to do number 22. I'll let you get started on this one, okay? I'm not actually going to do this problem for you, but you should know how to do some of these problems. So it's due east with, let me just write this down. It's going east at 345 miles per hour, and its true course is at 95.5 degrees from due north. If the wind is the wind speed is 55.0 miles per hour, what are the possible ground speeds of the plane? So ground speed, question mark. Okay, so there's lots of ways to do this. Let's look at this one. Let's look at the way they want you to do it. It's going east at 345 miles per hour, and its true course is at 95.5 degrees. 0, that's 90. It's going a little bit past to the fourth quadrant. 95.5. The wind speed is 55. Or you could go this way, 55. So you actually have two different speeds. You could have this triangle right here, or you can have this triangle. It's going, the plane is going east at 90 degrees, and as the headwind pushes against it, its true course is going to go a little bit slower. The ground speed is going to go a little bit slower. Or if the wind is pushing with it, they call that a tailspin. I'm sorry, not a tailspin. Tailwind, it's helping it move forward. Your speed is going to increase. So I'm going to draw these two triangles out for you, just a little bit, to help you guys get started. So that's your first one. That's your second one. This is 345. That is 5.5 degrees. Right there. That's 5.5 degrees. That's 345. And this is also 55, I believe. Yeah, the wind is 55. The wind is 55. So you have side, angle, side, angle, side, angle, side, ASS or SSA. You have to use the law. You have two different answers. So you can actually use the law of sines if you want at this stage too. The sine of 5.5 degrees divided by 55 is equal to the sine of, where's the angle? This side to that angle, we can't figure it out. So let's call this angle B right there. Sine of B over 340, angle B right there. Angle B over 345 degrees. You multiply by 345, get rid of that. To get rid of the sine, you take the sine inverse on the left side. Okay? So I'm going to do that on my calculator. sine inverse of 345 times the sine of 5.5 and Trig divided by 55. And that comes out to be approximately 36.95 degrees. So little b is approximately 37 degrees. And so that's 37. And you have to figure out what am I looking for? What this length is. So this is what I'm actually looking for. The ground speed here, the ground speed here. So I could use, since this is 37 degrees, it's going to be a little bit smaller. Actually, this is ground speed, so this is actually going to be 37 degrees right over here. Okay, because that looks to be 180 minus that. So 180 minus 37, and that's going to be 143. So we can, from here you can use the law of sines again. We know that this is a supplementary angle of the 37, just like what we did with the ambiguous cases. Okay. Hopefully that'll be enough to get you started for most of these problems. There's a couple more things to find the areas of triangles. If you have the SSS situation, side, the area, they use k value is equal to square root of s times s minus a times s minus b times s minus c, where s is equal to a plus b plus c divided by 2. The length of that, a plus b plus c, is called the perimeter, right? Isn't that the perimeter of the triangle? So S, another word for S, is called the semi-perimeter. Okay? So find the semi-perimeter, subtract it by A, subtract it by B, subtract it by C, find the product, and then take the square root, and that's what your area is given the three sides. Given the SAS situation, you can use the area is equal to 1/2 AB times the sine or cosine? Oh, nope, it's the sine of angle C. There is one other formula you can use. Of course, the area of any triangle is equal to 1/2 base times the height. That's another formula you're going to be using. I can't use A's because A stands for this angle, so I'm going to use K's here. There is one more formula that's a little bit complicated, and I don't have that memorized. So once you get it down, once you solve for one of the sides, then you can use, or the angles, you can use SSS, SAS, or 1/2 base times the height. Good luck on your test. There's a little bit of vectors involved. I'm not going to be doing too much with vectors. The previous problem right here, this is a vector problem. If the plane is going this way, and the wind is going, if the plane is going this way and the wind is going this way, that's your net vector. A plus B equals C. If the plane is going this way, the wind has a tailwind, then you're going a little bit faster because of that tailwind. It's pulling it from this tail. This is a headwind. So vector A plus vector B, tail to head, this will be your final vector. Okay? Good luck on your test, guys. Thanks.